Okay, for 18 I underlined key phrases. So Kevin, it takes them 7 hours to complete the job. Together it takes them 4 hours. And the question is, how long would it take her by herself? So the formula or the general structure of these equations, of these problems, is you take the unit rate of each one times the time that they work together, and both of those combined equal 1, and 1 represents the whole job. So for Kevin, he does 1/7 of the job per hour, and together he worked 4 hours with Laura. Okay, we need to find out how long would it take her by herself, so that's 1/t. Again, when she works with Kevin, they finish in 4 hours and they complete the whole job. So this equals 4/7 plus 4/t equals 1. The LCD here is 7t, so I'm going to multiply 7t by each term. So 7t times, and I know it's a little bit more writing, but it's worth going through the steps. So first thing on here, the 7 and the 7 cancel, the t and the t cancel, and on the right side nothing cancels. So you're left with 4t plus 28 equals 7t. So I'm going to subtract 4t. So 28 equals 3t. Divide by 3. And that's the time it takes Lara. So it's going to be 9 1/3 hours. For A, we're going to square both sides to get rid of the square root. So I get 4x plus 5 equals 9. I'm going to subtract 5. So 4x equals 4. And then divide by 4. X equals 1. For B, I'm going to subtract the 9 first. So that gives me square root of x minus 7 equals 3. Now I'm going to square both sides. So I get x minus 7 equals 9. I'm going to add 7. X is 16. For C, that 1/2, remember, that's the same thing as square root. So I'm going to raise both sides to the second power, like this. Okay, so now I have 10x, move 10x and 25 to the other side. Oh, sorry, I don't have to put equals 0 again, it's already on the left side. Quick correction, this is a minus, whoops. And so that's going to change that. And so that's going to make that a plus. And that makes that makes all the difference in the world. Because now I can factor this polynomial, or this quadratic, as x minus 5 squared. So x is 5. Alright, for letter D, we're going to raise both sides to the third power. So I'll just put it here and here. Excuse me. So that gives me x minus 6 equals 3x plus 24. I'm going to subtract x from both sides and subtract 24. So negative, this is gone, this is gone, oops, this is gone. So this can give me negative 30 equals 3x minus x is 2x. I'm going to divide by 2. So x is negative 15. And then for E, I'm going to first add the 1 to both sides. So that gives me x plus 2 to the 1/3 equals 5. And I'm going to raise both sides to the third power. That gives me x plus 2 equals 125. Subtract 2. X is 123. Over here, subtract 4 from both sides. Now we're going to square and add 10. Alright, so for A, we're asked to solve for number, actually A through C. And the first one's a quadratic. So I'm going to see if it factors, and it does because it's difference of two squares. Oops. That would be A. So 2x plus 5, 2x minus 5 equals 0. You set each factor equal to 0, and you get x is plus or minus 5 over 2. For B, that's also the difference of two squares, but it's going to be 4x squared minus 9 and 4x squared plus 9 equals 0. The first one factors, difference of two squares, 2x plus 3, 2x minus 3. The second factor, 4x squared plus 9, is not the difference of two squares, but we can factor it with imaginary numbers like this. Like that, equals 0. So from the first two, I get that x is plus or minus 3 halves. From the second two factors, I get that x is plus or minus 3 halves I. Okay, so C is the one that I enclosed in that red color. So that one, I checked to see if it factors, and it doesn't. So we're going to use a quadratic formula. I'm probably going to need a little bit more space. Let's see. I'll just do it right here. Okay, and so x is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So negative 4 plus or minus square root of 16 minus 20. So that's negative 4 plus or minus square root of negative 4. Okay, that's a 20 right there. And so 4 is square root of 4 is 2, and the square root of negative 1 is I. So this gives you negative 4 plus or minus 2i. No more radical. I can factor out a 2. And so the 2's cancel. So then the answer, the x, is negative 2 plus or minus I. Alright, for 21, you have a swimming pool with a sidewalk around it that is 10 units wide all around, like in the picture. So first they want the area of the pool. Well, for A, it's 20 times 30, so that's going to be 20 times 30, 600 square feet. The pool plus the sidewalk, well, the sidewalk is 2 feet wide, right? So it's 2 on each side. So it's going to be 24, because it's 2 on each side. So we're adding 4 by 34. And so that's going to give you 816 feet squared. Now, if they wanted you to know just the area of the sidewalk, then you would just subtract 816 minus 600. So that would give you 216 square feet. For part B, it's 10 times 15. So the pool, and I'll just put them in the same line. So 10 times 15 is 150 square feet. The pool and the sidewalk, they're adding 1 foot on each side, so that's plus 2, so that's going to be 12 times 17, so that's going to give you 204. And then to get the sidewalk, we take the 204 minus the 150, and that's going to give us 54 square feet. For part C, it's 20 times 35 for the pool. So that's 700 squared meters. You're adding x on each side. So that's 20 plus 2x times 35 plus 2x, right? Because it's x on each side, so it's 2x total. So when you multiply this together, again, it's two binomials that you're multiplying together. So that's going to give you, let me just go ahead, 700 plus 40x plus 70x plus 4x squared. So putting it in standard form, we would say 4x squared plus 110x plus 700. And I'll put it in parentheses because it's all that's 1 unit, meter squared. If you wanted just a sidewalk, you would take 4x squared plus 110x plus 700 minus 700, because that's a pool. That would cancel that. So you'd be left with 4x squared plus 110x meters squared.